In 1938, a highway worker driving along the newly built Route 1 stopped his car on a bridge above Big Sur. Below him, in the cold Pacific water, something moved. Dark shapes rolling in the kelp, cracking shells on their chests, diving and surfacing with a rhythm that no one on this stretch of coast had seen in living memory. Sea otters, roughly 50 of them, the last 50 on the entire California coastline. They were supposed to be extinct, hunted to nothing across a century of slaughter that killed over 43,000 animals for their fur. Pelts that sold for $1,500 each, $44,000 in today's money. Russian traders had come first, sweeping down from Alaska in the 1700s, stripping every bay and cove clean. American ships followed, 72 vessels harvesting 40,000 skins in 4 decades. By 1900, the species was considered gone. Marine biologists wrote their obituaries. Textbooks moved on. But the California Department of Fish and Game had known for years that a tiny group survived near Bixby Creek. They told no one. If poachers found out, even 50 would become 0. So the otters lived in secret, clinging to a sliver of coastline while the ocean around them collapsed in ways that would take decades to understand. When Life magazine finally published a photograph in 1938 proclaiming that the extinct sea otter swims back to life, the world celebrated a miracle. What no one realized was that the miracle was not just the survival of an animal. It was the survival of a force that had been holding an entire ocean ecosystem together for thousands of years. And in its absence, that ecosystem had already begun to die. To understand what the otters lost, you have to understand what kelp forests are. Giant kelp is not a plant. It is a brown alga, and it is the fastest growing organism on Earth. 2 feet per day. A single individual can stretch 200 feet from the ocean floor to the surface, then sprawl another 100 feet across the water in a floating canopy so dense it blocks the light beneath it. Scientists call it the sequoia of the sea. A single holdfast, the root-like anchor at the base, can harbor over 150 species. The forests themselves support up to 1,000. Rockfish, lingcod, Garibaldi, abalone, lobster, sea stars, seals, sea lions, eagles. A kelp forest is not just habitat. It is an underwater city. These forests once stretched along the entire California coast. They reduced wave energy by up to 60%, protecting shorelines from storms. They absorbed carbon dioxide at rates that rival tropical rainforests. A landmark study found that kelp forests protected by sea otters absorb up to 12 times more carbon than areas grazed to nothing by urchins. The global value of kelp forest services has been estimated at $500 billion per year. Per hectare, they are among the most productive ecosystems on the planet. But kelp forests have an enemy: purple sea urchins. In healthy oceans, urchins hide in rock crevices and feed on scraps of dead kelp that drift to the floor. They are small, cautious, and controlled. But when the animal that controls them disappears, everything changes. Urchins emerge from their crevices by the millions. They stop eating scraps and start eating living kelp, gawing through the holdfasts until entire forests collapse. Where there was once a cathedral of swaying green, there is nothing but bare rock and spines. Scientists call these urchin barrens, vast, empty underwater deserts where almost nothing lives. Urchin density explodes from 2 per square meter to over 100, and the urchins can survive on almost nothing, shrinking their own bodies to stay alive, waiting on barren rock for years. Researchers call them zombie urchins. This is what happened when the otters vanished. Not slowly, not partially. The cascade ripped through the ecosystem like a chain reaction. No otters meant no predator for urchins. No predator meant urchin populations exploded. Exploding urchins meant kelp forests were devoured to the sea floor. No kelp meant no habitat for fish, no shelter for invertebrates, no nursery for juvenile species, no buffer against waves, no carbon absorption. The ocean floor went from forest to wasteland. James Estes saw it first. A young researcher working in the Aleutian Islands in the early 1970s, Estes had been studying how the environment affected otters. His mentor, Robert Payne, the man who coined the term keystone predator, visited him in Alaska and told him to flip the question. Stop asking what the ocean does to otters. Start asking what otters do to the ocean. Estes spent the next 50 years answering that question. His 1974 paper in Science, written with Palmisano, became the foundational document of marine trophic cascade research. He compared islands in the Aleutians that had otters with islands that did not. The difference was so stark, it looked like two different oceans. Where otters were present, kelp forests thrived, urchins hid, and biodiversity flourished. Where otters were absent, the seafloor was barren rock covered in spines. He called sea otters an evolutionary component essential to the integrity and stability of the ecosystem. Over the following decades, he proved it again and again. A 20-year study across 153 sites confirmed the cascade was predictable and broadly generalizable. He demonstrated that as few as 4 killer whales preying on sea otters could transform over 1,000 miles of coastline from kelp forest to urchin barren. In 2011, he published a sweeping synthesis in Science called Trophic Downgrading of Planet Earth. In 2025, James Estes died. His ashes were scattered at Attu Island in the Aleutians, where he had first watched a sea otter crack an urchin on its chest and realized that one animal could hold an ocean together. Back in California, the 50 otters that had survived near Big Sur did what no conservation program could. They ate 25 to 30% of their body weight every single day. A large male consuming up to 25 pounds of food in 24 hours. Each otter devouring upward of 10,000 urchins per year. They cracked them open with rocks balanced on their chests, pounding at 45 blows in 15 seconds, storing a favorite stone in a loose skin pocket under their forearm, sometimes keeping the same rock for months. They targeted the largest, most reproductive urchins first, maximizing the damage to urchin populations with every dive. The kelp came back. Not everywhere, not overnight, but where otters returned, the forests followed. A landmark study published in 2024 tracked 100 years of kelp canopy data across California using satellite imagery and historical records. The result was unambiguous. In Central California, where otters had re-established, kelp forests grew by 57% over the century. In Northern California, where no otters lived, kelp declined by 63%. In Southern California, also without otters, it declined by 52%. Machine learning analysis ranked sea otter population density as the #1 predictor of kelp canopy change. Not temperature, not nutrients, not wave action. Otters. The cascade did not stop at kelp. In Elkhorn Slough, a small estuary in Monterey Bay, researchers discovered something that no one had predicted. Otters were eating crabs. The crabs had been eating sea slugs. The sea slugs had been eating algae that smothered eelgrass beds. With fewer crabs, the sea slugs survived, ate the algae, and the eelgrass recovered. A completely separate trophic cascade triggered by the same animal. A 2024 study in Nature found that otter predation in the slough had reduced salt marsh erosion by 80 to 90%. The otters were not just saving kelp forests, they were saving the coastline itself. If you want to see more stories like this, subscribe now. We are just getting started. And they were feeding an economy that no one had planned for. A study of Elkhorn Slough alone found that 45,000 visitors generated $3.2 million in direct annual spending and supported over 300 jobs. 71% of visitors reported seeing at least one otter. Sea otter merchandise accounted for more than 20% of gift shop sales at the Monterey Bay Aquarium. A regional economic analysis on Vancouver Island found that the benefits of otter recovery outweigh the costs by approximately 7-to-1. The Monterey Bay Aquarium built the world's only sea otter surrogacy program. When orphaned pups washed ashore too young to survive alone, they were paired with experienced surrogate mothers who taught them to groom, to dive, to crack shells, to wrap themselves in kelp while sleeping so the current would not carry them away. Over 30 years, more than 700 otters passed through the program. 37 surrogate-raised pups were released into Elkhorn Slough between 2002 and 2016, accounting for more than half of the population growth in that estuary over 15 years. One surrogate mother, a female named Rosa, raised 15 orphaned pups across her lifetime, more than any other otter in the program. She was euthanized in 2024 at 24 years old, one of the oldest southern sea otters ever recorded. The population grew, from 50 animals in 1938 to over 1,000 by 1972, to roughly 3,000 today. Their range stretches 375 miles along the California coast. But 3,000 is still only 20 to 25% of the estimated 12 to 16,000 that once lived here. The northern and southern edges of their range are not expanding. White shark aggregations near the Farallon Islands block natural migration north. And as of early 2025, federal efforts to study reintroduction into Oregon and Northern California have reportedly stalled under the current administration. The fishing industry opposes expansion. Sea urchin harvesters, abalone divers, crab fishermen, and lobster trappers all fear the loss of their livelihoods. The California sea urchin fishery, once the state's largest ocean export at 52 million pounds per year, has already collapsed by 93%. But that collapse was caused by a marine heat wave, a sea star die-off, and an urchin explosion in waters where otters do not live. The irony is brutal. The fishery collapsed precisely because the animal that controls urchins was not there to prevent it. In the summer of 2024, 2 sea otters were spotted off the Oregon coast, the first sighting in over a century. No one knows where they came from. No one knows if they will stay. In January 2025, a coalition led by the Confederated Tribes of Siletz Indians received $1.56 million, one of the largest grants ever awarded for sea otter recovery, to begin planning a reintroduction that indigenous communities have been calling for since the fur trade ripped these animals from their waters over 200 years ago. Peter Hatch of the Siletz tribe said it simply, "Since the beginning of time, when our newly created people's footprints first marked the sands, we coexisted with the sea otter." In 1938, 50 sea otters floated in the kelp off Big Sur, the last of their kind on a coastline that had once held thousands. They were not part of a plan. No one released them. No one funded them. They simply survived. And in surviving, they held together an ecosystem that everything else was trying to destroy. Today, 3,000 otters crack urchins on their chests along 375 miles of California coast. Where they returned, kelp forests grew by 57%. Where they did not, those forests collapsed. One animal, one appetite, one ocean, slowly coming back to life. The kelp is still growing, And somewhere off the Oregon coast, for the first time in 100 years, an otter is floating in water that remembers. But sea otters are not the only animal brought back from extinction that is reshaping an entire ecosystem. In England, 4 bison were released into a dying forest. Within weeks, they did what 18 years of human conservation never could. That story is right here.